Let's talk about ozone and why I regard it as being quite an important element of the air in your home. The reason for making this video is because I feature quite a few ozone generators in my videos. I take them apart, show them how they work, and each time I feel obliged to explain what ozone is in the first place. So I thought if I make one video that embraces the subject and shows what ozone is, how it's created, and its part in nature, then it'll save repeating that stuff over and over again. So to explain what ozone is in the first place, oxygen is composed of two atoms. A standard molecule of oxygen, O2, has the two atoms of oxygen, and under certain circumstances they can be separated apart. When they're separated apart, the singlet oxygen, the single atom oxygen, can sometimes attach to things and oxidize them, but other times it will combine with another molecule of oxygen or form a triple atom molecule called ozone, O3. The name ozone comes from Greek ozine, which means to smell, because it's got a very, very distinctive smell. But ozone is not stable. The ozone molecule wants to get rid of that third atom of oxygen and return to the stable O2 oxygen state. So when it actually touches an impurity, it could be volatile organic compounds, it could be mold, spores, bacteria, viruses, anything. It could just be inert surfaces, it could be clothing. It will attach on and it will oxidize it, but it does so at a microscopic level. So if you go outdoors, even in a remote area like an island or forest well away from civilization, you're actually breathing air that contains a tiny percentage of ozone. Air is composed mostly of nitrogen at 78%, oxygen at 21%, and the remaining 1%, just 1%, is composed of carbon dioxide, neon, helium, methane, krypton, nitrous oxide, hydrogen, xenon, and all the others, including ozone at just 0.0000001%. That's just 10 parts per billion. You think, well, that doesn't sound much. But gas molecules are so tiny that every breath of air you breathe contains around 10 sextillion gas molecules. That's the number one with 22 zeros after it. It's a very, very big number. And that means with every breath, you're actually breathing in 100 trillion molecules of ozone. And that's okay, because it's a normal part of air that humans and animals can breathe. Not just normal, but a very important part of air because it has a cleaning effect, the oxidizing effect I described earlier. It helps break down pollutants, it controls the spread of bacteria, spores and viruses by oxidizing them, it makes the outdoor air smell fresh, and it makes clothing dried outdoors smell fresh too because the ozone permeates it, and it's been doing so since the dawn of time. Ozone is a natural part of outdoor air. What makes the ozone interesting, that because it's a transient molecule, because it wants to get rid of that third atom of oxygen, it has to be created on demand. You can't store it. You can't get a canister and fill it with ozone. And if you open the door and let air in, the ozone will come in with the outdoor air, but in a sealed indoor environment, it will be depleted. Now, outdoors, nature regenerates the ozone continually using atmospheric effects, including photochemical and electrostatic reactions like lightning, rainfall, and sunlight in interaction with other chemicals in the air. Unfortunately, because these effects do not occur in enclosed spaces like our homes, and the transient nature of the ozone means that it rapidly decreases indoors due to, well, basically doing its job of oxidizing things or just converting back to oxygen, it needs to be replenished. So this makes it important to replace the ozone by either providing a flow of fresh outdoor air or creating the ozone on demand using the exact same processes as nature. Now, the best option here, and one that's been used for centuries, is just to have fresh outdoor air flowing through your house. But that does kind of mean opening the windows in your house and the air, opening one at the front, opening one at the back, and the air flows through your house and it brings in this continuous replenished supply of natural ozone from outdoors. However, with modern sealed houses and people needing hotter houses or just some climates, sometimes you don't want the window open. It could be pollen could be coming in from outdoors, it could be smoke from forest fires, it could be ice cold, or it could be extremely hot and you've got the air conditioning on, or you might just not want to actually leave your windows open in case like somebody breaks into your house, particularly while you're away from it. So that's when it comes interesting to actually create the ozone on demand. And I'm not talking really high power ozone generators. I'm talking just the tiniest little trace, not even having to match nature, just something in that direction that just replenishes it to a low level that will actually have the effect of keeping the air fresh, reducing any sort of mustiness and staleness in the air, and potentially preventing proliferation of mold in homes. Although obviously dampness also promotes mold and you have to deal with that as well, but it does prevent it sort of being spread through the air to a degree. So one of the ways to create ozone is using an ultraviolet lamp, and this is popular in catering industry ozone generators. So this is a UVC lamp, and it produces two wavelengths. Now, an ordinary germicidal lamp would just produce 254 nanometer UVC. But the ozone-producing lamps also, they have a much purer glass, and it passes another wavelength of the mercury vapor discharge inside at 184 nanometer. And it's the one at 184 nanometer that produces the ozone, but this is not an efficient way of producing it, because in the same way as the ozone layer works, which is this continuous transition between ozone and oxygen, it continuates, those atoms are continually moving backwards and forwards. In the same way as that happens, the 184 nanometer produces, it splits the oxygen apart into the ozone, allowing the ozone to form. But then the 254 nanometer, ironically, helps combine it back into oxygen, so it defeats the purpose to a degree. So they're not efficient. But with an airflow through these, it's worth mentioning you can't expose your skin to these when they're lit, because it causes skin irritation and eye damage, like an arc flash from welding. But in the catering industry, they do like these because it's a very convenient and known, consistent way of producing a certain amount of ozone, even if it's less efficient. And that's quite useful, that it's just that consistent output. It means they get a predictable quantity, and all they have to do is change the tube every so often, so it makes it a fairly maintenance-free application. The other approach is corona discharge, and this is where I have to differentiate that the corona I'm talking about is not coronavirus. The word corona is Latin for crown, and the coronavirus is the name because it's got little crowns on the end of its little thingies that stick out of the ball that's got the virus stuff in it. Ironically, the little crowns that actually latch in are the ones that get damaged by ozone in the air, and that kind of can assist in deactivating the virus, making it less effective. However, the corona I'm talking about is corona discharge. Again, it's crown shaped, but if you can imagine a spike with an electrical discharge on it, it creates lots of little tendrils of glowing air, and that is why it's called corona, because it's the crown. It's a glowing plasma. So for big industrial applications, they apply high voltage across either side of a plate at high frequency. And what happens is that these little electrodes here, you get a sort of coupling capacitively through the plate, but it creates a sort of corona discharge next to these strips. But these are only suited for like major high levels. You get them for hotels or used car dealerships where they want to get rid of a smell out of a smoked-in car, or a smoked-in room, or vomit or other things that are undesirable. And you don't want to breathe in the amount of ozone that these produce, because in a small room this will produce far too much, and it will pose a sort of health problem. It's pretty much like chlorine in a pool. The natural level of chlorine you'd expect to find in a swimming pool is, I think, around about 5 parts per million. Above that, it would become an irritant. It would make your eyes sting. And the exact same thing happens with ozone. There is a rough rule of thumb. If you can smell ozone, there's too much. But to be honest, by the time you can smell it, there's already about twice as much as you want in the room anyway. So it's better kept at low levels. So this is one way of doing it. The dielectric barrier cold plasma, sometimes they call it, corona discharge ozone generator. Another more common approach for smaller, lower levels is a device like an ionizer. Now, ionizers, their primary purpose isn't to create ozone. It's just a happy coincidence side effect that is so low level that, you know, it doesn't even compete with nature. Opening the window and letting air flow in would not produce any, would produce a lot more ozone in the air than just running one of these. But the purpose of the old traditional ionizers, I'm plucking the little needle here, bing. The point of these is that when you apply a very high voltage to a spike, a conductive spike, the area of charge on a surface is highest at a sharp point. This is why things like Van de Graaff generators and Tesla coils, they've got big domes on top, because any sharp pointed surfaces, the electricity will basically start charging the air and leaking out at that point at those voltages. But in an ionizer, that's what's wanted, because by presenting the high voltage, a high negative voltage in the case of an ionizer, onto a sharp point, it creates a very strong charge there that actually puts electrons onto the air, charges the air, and then they repel away and you get a draft, and it puts an electrostatic charge in the air, and that electrostatic charge is referenced to the ground, and it charges dust at microscopic levels, negative to with respect to ground, and basically the dust precipitates out onto the walls and it makes a huge mess. That's why they're quite unpopular, but they work. That mess would have been in your lungs otherwise. However, if you look at these when they're operating in a very, very dark room and you let your eyes adjust, to be honest, these days, just use your phone camera, because it can see in the dark better than you can. Go into a dark room, focus on the front of one of these units and then turn the lights off so it's completely black, and you'll see a tiny little glow at the tips of the needles. That's the corona discharge, and it produces that tiny, minute trace level. So that was a benefit of the ozone generators, of the ionizers. Unfortunately, the ionizers got a bad rap because people put out things like these and called them ionizers. Let me let you hear this. This smells of ozone. This is putting out a high amount of ozone. People call them ionizers. Technically speaking, it does ionize in a way, but it's not an ionizer in the traditional sense. However, there's another approach to ionizers, and that's scaled up here. I'll show you the first version. These little things in here are carbon fibre clusters, little clumps. And if you zoomed up with the microscope, it would look like the end of a paintbrush. Lots of little tiny fibres. And the huge advantage of them is that, as opposed to old units that used a pointy needle, which wasn't that pointy in molecular terms, these things have millions of tiny little points, so they make very good ionizers. They emit the ions into the air very well. And an interesting approach to these now is the use of a positive and a negative cluster next to each other. So you've basically got two little clusters of these carbon fibre emitters. One is positive, one is negative. What actually happens is, because they're right next to each other, and because of the high voltage, the ionized air flows straight across, but the main benefit is that you get that tiny little corona discharge, very controlled portion, and it's just a very convenient way of a maintenance-free way of creating that. Other things like this is you have the spike and ring, very popular in Chinese products. For Chinese and Japanese products, they've already embraced ozone indoors and for sterilising cupboards and fridges and keeping them fresh. But this is the inside of a sharp plasma cluster from Japan, an early one. It's got the metal spike there and then the ring in the vicinity. And that is much like that one I just let you listen to there, that small one down there, that was making the hissing noise. Because the needle is in the vicinity of the opposite polarity ring, it creates a very high airflow there, and it also enhances the plasma, the corona discharge needle, and it just creates an airflow, and it also creates that high level of ozone. Sharp doesn't like to say ozone, but they say hydroxyl radicals, and it does produce hydroxyl radicals. That's an atom of oxygen and an atom of hydrogen, which also has transient effects. It's useful. There's various forms of that. I'm kind of going in the biasing to this style as being very interesting. The one I showed you is ancient. That's been around so long. Inside this is a metal plate with holes, and then just a zigzaggy metal strip with points and a high voltage generator. I made a video about this. It produces a high output. This is what I'd say a whole house unit. They sell it for cars. I wouldn't recommend it for cars. So, now we've covered that, let's talk about the people who have already gone down into the comments in this video. And they've already left messages in the comments without watching the video. They actually just searched the title Ozone and then came to impart their wondrous knowledge, which is not backed by scientific facts. But they'll say things like, there will be comments down there that say, any level of ozone is dangerous. Well, ozone exists at 10 parts per billion in nature, so if it was dangerous, you'd be dead. Okay, next. For extra emphasis, they'll often say, ozone causes cancer. There is no evidence that it causes cancer, but excess ozone is an irritant, much like excess bleach in a swimming pool is an irritant, and chlorine gas is an irritant. Yeah, it's not good in huge quantities, but that's only found in industrial applications. And then their final thing that these people tend to post is, what about the wee babies? Well, the babies are designed to breathe ozone at 10 parts per billion because it's a natural level, and from the point they're born, from the first breath they take, they're designed to deal with it. They are designed to deal with natural ambient levels of ozone. Otherwise, there would be no humans or animals. We're all designed to deal with it. And you can deal with a certain amount before it starts giving health problems. So next, people often point me in the way of the Environmental Protection Agency. I've looked at their website. I looked at two websites while I was researching this. I looked at NASA's website, and it was full of amazing, just tons of totally documented data. Really fascinating. It's a great website. I didn't realize NASA's website was so good, but it contained all the different levels of ozone from the stratosphere down to the ionosphere and the troposphere, which is where we are. We're in the troposphere. It's where all the trees and houses, and we are. But anyway, then I looked at the EPA. I think they may employ Karens as scientists. I'm not going to be too nasty about this, but I got the impression that the EPA just went to extremes. They said indoor ozone generators. They'd obviously gone for the ones that got a bad rap, like the sharper image was ionic breeze. Theirs was great, but it was too powerful. It would have been great for a big building, but it was actually too powerful. It was really interesting scientifically, but you could smell the ozone hissing out the front. It was way too much for a typical room. But everything they seem to say in their website is based on things like that. And they also say things like, the high levels required for sterilization and killing everything in a room would be dangerous for humans. That is absolutely correct. But nature produces low level deliberately because it doesn't want to kill everything. It's just, without it, the air would be rank outside. It's needed at low levels, but it doesn't want to kill everything. That's not the point. It's the reason, getting back to the swimming pool, that you put a small quantity of chlorine in the pool just to keep it sterile. It's not going to kill all the humans that go into it. The other thing they say is that ground level ozone is bad. Pollution causes high levels. They're absolutely right. Mother Nature she designed ozone. She uses that to regulate pollution. The more pollution there is, the more ozone will be generated to counteract it. That's not just the pollution from exhaust pipes. It's the pollution from oily vapor producing plants in nature. You'll get high levels of ozone naturally in random locations like that. But they point out that the high levels of ozone associated with pollution causes breathing problems in people who already have breathing difficulty. And the point there is their lungs are partly compromised. But also, don't you think it's actually the pollution that's the real problem and not just the ozone? It's the fact that the pollution there is actually just as part of the villain in this thing as the ozone that's trying to defeat it. So that's a very odd thing, but it gets worse. EPA science. Let me read you some EPA science. In one study, Shaughnessy and Oatman, 1991, a large ozone generator recommended by the manufacturer for spaces up to 3,000 square feet, note 3,000 square feet, was placed in a 350 square foot room. So that's a room 10 times smaller than what it's designed for. And run at a high setting, oh, that's making it worse. The ozone in the room quickly reached concentrations that were exceptionally high, 0.5 to 0.8 parts per million, which is 5 to 10 times higher than the public health limits. No shit, Sherlock. You used an ozone generator 10 times, rated for a room 10 times the size, and it produced 10 times as much ozone. How could that happen? Do you want to borrow my calculator? I mean, I'm not being facetious or anything, but it's not very good science, is it? But they also suggest that they've tried loads of other ozone generators, and it looks like they've been using really high output units, and they report that some of them produced excessive levels. No kidding. But then it says the concentrations reported above were adjusted to exclude that portion of the ozone concentration brought in from outdoors. Indoor concentration of ozone brought in from outside, they were in there already when they opened the door in the first place to begin the experiment. They're typically 10 parts per billion to 20 parts per billion. It could be as high as 30 to 50 parts per billion. If the outdoor portion of ozone were included in the indoor concentration report above, the concentrations would have been correspondingly higher. I think not, because if you opened the window and let that air in, the air wouldn't just come in. It's not like the pressure just keeps increasing like a balloon. It comes in, it has to go somewhere, it'd be pushing the other ozone in the room out, and therefore the net result would have been lower. This makes as much sense as saying, we added 10 times as much chlorine to a swimming pool and everyone got a rash, or we connected a 12-volt lamp to 120 volts and it exploded. So, EPA science? Let me show you what to do with EPA science. It's rubbish. But anyway, I'm sure there's good science, and there's the novelty of looking at their website wore off. Back to NASA we go. But that's ozone. Now, I do have a little ozone meter here. I have been so disappointed. I've tried so many ozone meters. The problem is that you're talking about something that exists at very low levels, and the meters are very sensitive. They can pick up other things. It's picking up just the fact I've picked it up has registered an ozone level, which is now dropping off to 0. But unfortunately, I know there's ozone in this room. Yeah, it's yo-yoing up and down. It's being affected by something, but it's not the ozone germ in this room, because this thing tends to zero itself out. And the reality is that the ozone detectors are really expensive, and they're very fickle, and they have a short life, and they have to be looked after very carefully and used X amount of time. You can't just leave them in storage, and you have to recalibrate them all the time. So having an ozone detector, I mean, it would be great if you had, say for instance, not quite this, but an ozone generator that reacted to the amount of ozone in the room and just kept it at the same levels as outdoor. But it's really hard to measure. Not easy. So my approach with ozone is to say that instead of trying to emulate outdoor levels, just put out the tiniest sniff and don't put out big bursts of ozone. Put the tiniest sniff into the air continuously from something like this, or the Sharp Plasma Cluster. I mentioned the Sharp Plasma Cluster because it's very, very interesting for another reason. But something like this that's designed to just drizzle out the tiniest little trace of ozone, or something like this that does the same, is a good option, because I don't think you need as much. It's not like the indoors is as organic as outdoors. You don't need the same level. 10 parts per billion outdoors, maybe 2 or 3 parts per billion is fine indoors, just as long as it's there to actually keep things in check. I mentioned Sharp Plasma Cluster because the Japanese have always embraced these units, and they don't necessarily use the word ozone. They use the hydroxyl plasma clusters and things like that. But the main thing is that for 20 or 30 years, they have been using them a lot. Like almost every home has a unit in with something resembling these days this, or in the older days it was this, and it just hisses in the background, and it's got a powerful fan that cleans the air, and it does clean the air with a filter. Ozone does not actually take impurities out there, it just deactivates stuff in the air. That's its main advantage. But the Japanese have been doing this research for us. So if we research, if they also wear masks, which is a bit annoying, it skews the results a bit. But it'll be interesting to see how they fared during the coronavirus pandemic, because all their hospitals and public buildings and stations and their homes have these units producing trace levels of ozone and hydroxyl radicals and other active air components that are naturally replenished outdoors, but not normally indoors, except with these units they are. But ionisation goes back a long way. It's not new. The Chizhevsky chandelier is something that's worth looking up. And that's more or less it. So now you can go down into the comments and tell me exactly what you think, and you can pick holes in my research if you wish, and you can say I'm right or I'm wrong, and you can contribute to it. And if I can think of anything else, I'll actually put it in the description down below. But that is my take on ozone indoors. Trace levels of ozone are good.